Helen works at Goddard Space Flight Center, and she has many hats that she wears. But one of the most important hats that she wears, from my perspective, is the hard work that she's doing on making sure that the data that is collected and reported in the GLOBE database is of the highest quality possible so that we can support excellent science. And so we've been very excited to have Helen speak today. We had to wait a long time till it worked out with her schedule. So this is definitely going to be a treat. And if you don't know Helen, she's a wonderful scientist, and she also will entertain all your questions. So go ahead and put any questions that you want in the chat, and and Cassie and I will monitor those. And then at the end, we can ask Helen if she can clarify any points. So as you think of something you want to know more about, please go ahead and put that in the chat. And without further ado, I think I would like to turn the control over to Helen.
All right, thank you very much, Rusty. Let me cue up the slides. Really, it's a pleasure to have folks here. I know everyone's time was so valuable, so thank you for taking an hour out of your day to join us for this talk. And I think it's really amazing, you know, as people are putting their location in the chat, and it's like no two of us are in the same location, which really says volumes about this community and how geographically spread we are. And I think that is so cool because we're all seeing different things and add so much to the database because of it. So what I've been asked to talk to you guys about is sort of behind the scenes, what happens to your data. I spend a lot of time looking at the data. And so I'm gonna share with you what I'm finding and give you tips that you can spread the word about, so that when folks are going out and making mosquito observations, that they can make the very best observations that they possibly can. But first, I really owe everyone who goes out and makes observations a huge thank you, right? Like this, you know, I am only a tiny, tiny, tiny piece of this program, and we owe everything to our citizen scientists. This is a snapshot of what the current coverage looks like for mosquito observations coming from you guys, and it's just amazing. So I've been in my job for a year, and to watch this map populate with data week after week after week is a pretty incredible thing, something I really enjoy. So kudos to you guys. Please thank everyone you work with and everyone that you go out and do science with. It really is a really impressive thing. Since most of you haven't met me in person or professionally, I thought I would take a second to tell you about who I am and how I got to my current position. So let's see, can you see my cursor on the screen?
Yes.
Great. All right. So this image here, so I was born and raised in a place called Enumclaw, Washington. That's this lovely place with the mountain and the farm and the tractor. I now live in the other Washington, in Washington, D.C., where I work at NASA. I live here with my young family. This is my son, Nicholas. He's 18 months and just never a boring moment in my house. He's really a pleasure. How did I get to my current position in NASA? So I went to University of Washington in Seattle, where I studied mathematics and atmospheric sciences. From there, I went on to go and study computer modeling and air quality at Harvard, which was a really, really, really great time. After I went to go for the US Environmental Protection Agency, and that's where I got a taste of citizen science. And from there, I joined the team at NASA in 2018, and I've been here since and hope to be here for a long time. It's a really great place. And I always think it's a fun place to start as an icebreaker. So fun fact about me is I'm a twin. I'm probably thinking, are we identical? And the answer is yes. So we are mirror image twins. I still think it's weird, even though it's me. Okay, my job at NASA, what do I do here? So I work at NASA Goddard Space Flight Center. It's in Greenbelt, Maryland. We're having an absolutely perfect fall day today. And my job here is as the science outreach lead. And what that means, so I am a happy camper when scientists are coming to me to ask about how they can use the data in their research. So I am trying every day to increase the number of people who are looking at the data and using the data in the science. And so I think what Rusty said at the beginning hits it on the head. I care a lot about really high quality data so we can do excellent science. And that means whether that science is being done by NASA scientists, whether it's being done by folks in their own home, students in the IVSS, or our fabulous interns that several of us work with this summer. So all science needs high quality data, so I think about it day in and day out. Doing citizen science at NASA is really, really, really great because NASA really does a great job with citizen science. GLOBE is part of a broader sort of ecosystem of citizen science at NASA. So all federal agencies have the authority from Congress to do citizen science, but NASA is really a leader in citizen science. It's very enthusiastic. It really supports citizen science. And so if you haven't already checked it out, I just wanted to let you know that the site, so nasa.gov/citizen science exists. This is just a snapshot of what that landing page is going to look like. And you can find out more about the projects that are active right now at Citizen Science, and you can find out how to join them. And there's more information here. And here's our lovely, lovely GLOBE. So GLOBE, if you aren't already familiar with the GLOBE Observer app, you can get it for free for either Android or Apple devices. Just go to observer.globe.gov. We're going to be talking about the data that comes from this app for the rest of this talk. The Mosquito Habitat Mapper is one of the tools inside of the app and is the workhorse of GLOBE Mission Mosquito and is the tool being used to collect and submit all of the mosquito habitat data. So what's in an observation? So you download this app, you go into Mosquito Habitat Mapper, and there are really 4 components of an observation depending on your interest, your ability, and sort of how much time you have. So the first component of an observation is to locate potential habitats. So here I've got an example of a tire, a classic mosquito habitat. They love icky, stagnant water. And this is where female mosquitoes can lay their eggs, and that's where you're going to see the larvae. So step 1 is locate these little guys. Step 2, if you have time and the sort of the interest to do this, please do. We really, really love it. You're going to take a vessel and scoop some of this water out, and then you're going to count approximately how many you see. Again, if you have enough time, the third step is to go a little bit further with a clip-on microscope. You might try to identify the kind of mosquito that you see. There are thousands of kinds of mosquitoes, and not all of them have the ability to transmit diseases. And so we're trying to figure out on the app if you have a mosquito in front of you that is potentially able to transmit diseases like Zika or dengue. And then the last step, dump out the water if you can. You know, if it's a huge pond, you can't dump it out, but if it's something like a flower pot or a drip pan under an air conditioner or a tire and you can eliminate the habitat, please do. So those are the 4 components. And this is going to be really kind of the backbone of what we talk about, is sort of how for each of these components can you do the best job that you can sending in really high quality data. But first, I want to show you sort of how popular the different parts of the app are. And this is work that I did. So with Jacqueline this summer, she was an intern that I co-mentored out at Jet Propulsion Laboratory in California, and she was really fabulous. And what she found is that, so she did an analysis where she looked at the number of responses for every question in the app. And so down here on the x-axis, these are the different steps in the app, starting with, so this is the water source. This is sort of step 1. Here's that larval count. That's at step 2. Here we're getting into the photos So trying to identify, these are step 3, and here's that dump out the water, that's step 4. Here are the number of observations. So out of about 15,000 observations, right? So folks are really doing an awesome job, awesome job across the board, but are really enthusiastic, and a lot of responses are coming in for that part 1, for the water source type and dumping out the habitat. I love this part, that people are very willing to dump out the habitat. That's such an important way to protect your community from the spread of disease. Fewer people are doing the identification and the count, and that is okay. The app was designed for people to sort of do what they have the time to do. This is just to show you the activity that we see in the app. And also to give a shout out to Jacqueline. She was just such a super intern. She was really great. So whether you go all the way to the end and you tell me that you have identified an Anopheles mosquito, or whether you stop at just telling us that you have mosquito larvae in a tire and stop there, wherever you go in the app, you're going to eventually hit send. And now I'm going to talk to you about what happens after you hit send to make sure that your data gets approved and into the database, and again, how it can be the highest quality that you can make it. So here's the end. You're going to hit send, boop. If you're on Wi-Fi, it will go over your Wi-Fi signal. If you're on cell signal, it will go over your cell signal. And then if you included photos, they're going to go to photo approval. So we actually have a whole team of people doing photo approval right now, but Kristen Weaver, she sits here with me at NASA Goddard Space Flight Center. She's absolutely incredible, and she's a really, really active photo approver, and so she's going to say yay or nay to whether or not your photos can be displayed publicly. And then your data goes live. So this is just a snapshot of what we call the Globe Visualization System. And really within minutes from hitting send, she gets an alert. She looks at the photo, and if everything looks honky-dory, it goes live, and you can see your data. Usually by the time you get back inside, you can see your data live. So how do you make sure that your photos get approved? The really big one, don't put faces in it. As much as it is fun to take a selfie, this is not the data set for selfies. So here's an example. Both of these photos have people in them, but here's a great example of if you're going to have someone in it, make sure that their face isn't displayed. So in this photo, this person is doing such a great job. So you see the habitat where the mosquitoes are living. So this is the flower pot. You can see the woman sampling. So here she's doing it with a spoon so that she can pull out the mosquito larvae and identify it. But you can't, you could never identify this individual person, and that's perfect. This is such a great photo. This one had to be rejected because we can identify multiple people. So the easiest way to make sure your photos get approved, and really the way to make sure they get approved, is obscure faces and make sure, if you have someone in it, we can't identify that person's face. I'm going to talk a little bit more about photos. They're so important. A photo's worth 1,000 words. These will not get your photo booted, but I will tell you, in making sure that we have the best data set possible to support excellent science, these are issues that we're noticing, so I'm passing this information on to you. And one is, make sure to only submit a photograph once. So we were noticing, I think a lot of us were manually looking at the data and noticing some of the same photos were showing up again and again, and they were being submitted multiple times. You only need to submit it once. Once is perfect. So this is work that was in the summer. Other JPL intern, JPL is the Jet Propulsion Laboratory, and he wrote a Python script to automatically detect and flag repeated photos. So when we're doing science, we just need the photo once. So no need to send it multiple times. Instead, you can move to a different location, find a different habitat, and make a separate one. Because what's going on in the sort of behind the scenes is we're running Canon's script so that I can see which ones are flagged as repeats, and then those will be excluded from analysis. So only submit your photograph once. We love, love, love photos, especially when you get to the point where you're trying to identify what kind of mosquito you see in front of you. But do make an effort to submit clear photographs. Here's an example, and I will tell you, this is hard. This is really hard. I've done it with multiple different clip-on microscopes. It takes some practice. It's really challenging. But gosh, when you get a clear photo, it is so valuable. So here's an example of a photo that came in. This is really super crisp. You can see the mosquito's head. You can see the siphon. You can see these little tufts of hair. If you zoomed in, you could actually even see the comb scales right here. You can see the pecten. Like, this is just awesome. I love this photo. This one, I've looked at so many of these photos and I've done this myself. What I would guess is actually going on when you see sort of the sparkliness. Sometimes that can be if you've tried to immobilize the mosquito in hand sanitizer. Like if you put a dollop of Purell on top of the mosquito, that can sort of lead to the sparkly effect that really all you can tell is maybe here's a head, here's a body, but you really couldn't say whether this is, an Aedes or a Culex. And so keep trying. If this is you, I've been that person. I was that person for a long time. It's hard. If you want tips, let's talk afterwards, but please submit clear photographs. And don't let any of this discourage you. So hopefully taking photos is really easy and doable. Please keep doing it. The context is so useful. This is just to show sort of an example of great photos that came in recently as I was making this talk. Benin in Africa has been very active. Here they're finding mosquitoes living in a trough. It's so useful to see the context. And then here's an example of the mosquitoes that they're seeing. This is great. You can see the shape. Some of them have more oval shape, and these have more sort of teardrop shape. You can see the siphon. You can see the little fuzzy hairs on them. So please keep submitting photos. All right. I think I've said enough about photos, so I'm going to talk a little bit more about the other aspects of the data. Really high quality data that's super valuable for science includes larva count. We want to see sort of how abundant are the mosquitoes, so when they show up, are there lots of them, or are there just a few of them, and how is that changing over a season, and even better, how is that changing from year to year? So here's my tip. I've done this. I've made a lot of messes in my office. I think my office mates think I'm a little weird. That's okay. So you'll take a vessel, you scoop out your stuff, and then I like to use a paper plate. And I actually like to mark it. So, if I had something like this and there are a lot of mosquitoes, it's hard for me to count all the mosquitoes in one go. So what I like to do is I like to mark sort of a big cross on my plate, and I use pencil because I've tried using pen, but then when you dump the water on there, the marker just bleeds everywhere and you can't see anything. It's actually really hard to see your mosquitoes. And so using a pencil, it won't bleed. So I'll mark it into 4 sections. I'll dump out my mosquitoes and then I'll count section by section. And on the edge of the plate, I'll write the count. I'll write like 25 in here and 37 in here and 42. And then at the end, I add up all of the pieces. So please include count if you can. And if you're having a hard time keeping track of your count, like I was keeping track, someone smarter than I am taught me about this tip and taught me to use pencil. So I'm passing it on to you guys. Count is really wonderful. It's also really great if you can keep doing this over time. This is also work I did with Jacqueline this summer. And this is figuring out sort of who's going back and making measurements again and again and again. And this is so valuable because it creates a record of what's going on at a particular site. And that's really important for comparing to things like satellite data. So if you think about what's going on with the satellite, so satellite is orbiting around Earth. So it might be coming every day or every, 15 days, but over time it's creating a record of, say, precipitation or vegetation at that site. And by you doing the same, so come back to the site again and again and again, coming back once a week is great. You're creating a time record that can be compared to satellite records. And that's something that I'm hearing, as I'm talking to scientists here, that's what they're most interested in are the sites that have records that extend over time. So here's a shout out if anyone on the phone or anyone on Zoom here is from these places. These are currently the sites that have at least 30 days of data. So Shoemake Middle School, Columbia Globe Fee School, Escola Minas, and Lycée Thamalka. So keep up the great work. Here's an example from Escola Minas of what this looks like. So here they've done larva count, and larva count's really important to know sort of when the mosquitoes are showing up, and do you have a lot or a little of them. And they've, look at them go. Here they are, July 2017, November, January, March, May, now we're into 2018, now we're into 2019, like they just keep coming back. And this, so Jacqueline was able to pull their data because they have data over time and compare it to satellite data. Pretty cool. So if you have the ability to keep going back and observing at the same site, please do. All right, so like I said in the beginning, we have sort of these four components. We have you're finding the habitat, you're photographing it, then you're going to count the larvae, you're going to follow the app inside to identify, and at the very end, if you can, dump out the water. This is so important for sort of eliminating potential habitats in the area where you live and helping stop spread the potential, stop the potential spread of diseases like West Nile and malaria in your region. So if you can, please do dump out the water. Also at the end, in the dump out your water, I'd be curious, you can let me know in the comments if you use the comments field. So another tip for a really great, super high quality observation is to tell us about what's going on in your area. So this shows up, there's this little comments field. So you're in the app. This is step 4, and it's asking you, did you dump out the water? I hope you can say yes. Even if you say no, either way, yes or no, leave us a comment. So this is my comment. In DC, we're officially in a drought. It's unbelievably dry here. Everything is parched. And because of that, actually, where I live, the mosquitoes are really, really, really intense. And it's because I live near a stream, and when the water is high, the water is moving. There is nowhere for those mosquitoes to live because mosquitoes want stagnant, still water. But now that it's really, really dry, the stream is so low, and it's actually too low to flow, and it's just these stagnant pockets of water between the rocks, and the mosquitoes in my yard are unbelievable. And so I made a comment here that we're in an unusually dry summer, and when I reported my count, it was a lot. So use this comment to tell us things like, it's been really hot, it's been really dry, or we've experienced recent flooding in my neighborhood. If it's a test, you can tell us it's a test. So if someone's filtering the data for science, they can filter that one out maybe because you're just sort of getting used to the feel of the app. You can tell us things about the place, like it's an abandoned lot. Science has shown that abandoned lots and abandoned trash create extra habitat for mosquitoes. So anything you can tell us about the weather, about your environment, please do. So you're going to dump out the water, leave us a field note, hit send, and then you might be wondering, is that it? Could I do more? And the answer is yes. Take 30 more seconds if you're able to. You're going to go back to the home screen. So in the app, what it looks like is you're going to click on this. Take 30 seconds and do a land cover observation. It's right below mosquito habitat mapper. So these are actually photos of land cover submitted by citizen scientists like yourself. So this is in Ghana, Africa. Pretty amazing. Mosquitoes live in both of these places, and by having, so the land cover connection is so important because it's really providing more information about the habitat where you're finding these mosquitoes, and it gives us additional photos to understand, oh my gosh, you're really in a place like this, or wow, you're really in a place like this. These kind of contextual clues are really valuable. So if you've got 30 more seconds while you're outside, before you go inside to start identifying your mosquitoes, do a land cover observation. I can't emphasize the importance of this enough. Okay, so let's do a quick recap. So tips for making great observations. And I will say the majority, I've looked at so many observations, the majority are really, really high quality. So this is sort of a small portion, but anything we can all do to be making great observations, keep it up. So photos, photos, photos. Those photos are so valuable. Just make sure your face isn't in them. When you submit, make sure they're clear, and make sure that they're original. So no need to submit a photo more than once. If possible, please report that larval count. This is really important for the science. Keep observing over time, going back to the same site. Going back once a week is really great timing. This allows us to compare your data to things like satellite data. And if you've got 30 extra seconds while you're outside looking at the mosquito habitat before you go inside, do a land cover observation. And one more time, keep up the amazing work. So in the beginning, I showed you a map with the coverage of mosquito observations, but holy moly, look at this. This is another way to display the data, and I'm just blown away by people's participation in this program. So this is the amount of data. So that's about like 1,800 observations in 2017. Here we are in September 2019, and we're approaching 18,000 observations. That's incredible. So give yourself a pat on the back. You deserve all of the credit. Sort of our community is really, really, you guys make me choke up a little bit. You're pretty amazing. All right, if you want to stay connected with the Globe Observer program and you're not already connected, check us out on Twitter. There's a lot of really fabulous mosquito content up on there. What goes up on Twitter often goes up on our Facebook account too, so nasa.globeobserver. And if you want to get more involved with other NASA citizen science projects, say something like astronomy, check out Sciencing with NASA. This just went live and it's a really fun group. And if you're keen to keep reading and you want to know about how scientists are using the Mosquito Habitat Mapper tool and the data, shout out to Ekpan et al. That just went out. This is a really great study in Benin. And if you want to read more about the summer research that Jacqueline and Kanan did this summer as NASA Jet Propulsion Laboratory interns, check out their blogs here. And thank you to Rusty for posting these up on the Mission Mosquito Science Cafe blog. All right, with that, I am happy to take questions. I haven't been following the chat, but I can see it's going live. All right.
So we've been answering the questions as we've been going,
Thank you.
Helen. But I think now that you have officially concluded your slides, I'd like to do a call out for people that have specific questions for Helen as well. She just gave us a lot of really exciting material. And while we are talking about, waiting for you to write something down, I wanted to let you know that when she was talking about the importance of land cover, one thing that we found out when we went to go talk to entomologists, they're saying, oh, this is the one thing that makes the Mosquito Habitat Mapper a tool that can't be found anywhere else in the world. And that is the fact that we collect data all in one place. You can stand in one place and get trees, you can get land cover, you can get clouds, you can get mosquitoes. And they see that land cover data is one of the most explanatory parameters that they use when they're trying to do modeling. So that's why we're really trying to make sure that people realize how important it is to do those too. So I want to thank you, Helen, for stressing that. And there's another question here for you, Helen. Are there some studies about mosquitoes that like muddy water? And if you have something to say about that, go ahead and then I'll answer it.
Take that. Yeah, I mean, the short answer is yes. But Rusty, I'll let you take that one.
Good. Thank you so much for the short answer. And the answer is, there are tons of studies, ecological studies, about what kind of water conditions mosquitoes prefer. And if you read old literature, what you'll find is they'll say, okay, Aedes mosquitoes, which are the Asian tiger mosquito, the yellow fever mosquito, and many other kinds of mosquitoes, they tend to prefer clear water. And that Culex mosquitoes are the mosquitoes that prefer kind of stinky, eutrophic, dirty water. And what we have found, though, recently is that that breakdown doesn't really work anymore, because what's happened is mosquitoes are adapting to whatever they find. And so both clear water and eutrophic, by eutrophic I mean lots of nutrients in it, dirty water, that water is also really also used. So there are lots of studies, and if you want some help in finding some of them, Maria, just let me know and we can go look for you. But thank you for the great question.
Ooh, Maria, you asked a really good one. So Maria asked, are there studies that correlate aerosols like Saharan dust and diseases spread by mosquitoes? So I'm not aware of the correlation between Saharan dust and mosquito-borne diseases, but there are correlations between aerosols and disease. So aerosols have the ability, aerosols are small particles suspended in the air that can be host for pathogens. So an example in like Arizona, the dust can transport valley fever, and it's actually a fairly significant health concern. I want to give a quick shout out for Globe Dust. So actually let me stop sharing my screen, and I will pull it up for you, Maria, and I will share it with folks in the chat. Did you know, so in the Globe Observer app, you can actually report dust events, and we really, really want you to report dust events, and there's a special call for dust, and there's actually a brand new web page with dust resources. So I would, if you're in an area that is experiencing Saharan dust, please, please, please submit it, and I will share resources with you about how to make that observation with the Globe Observer app. Great question. All right, I am pulling up the dust resources. I'm not monitoring the chat. Rusty or Cassie, will you let me know if something else comes in?
Yes, I will. And there is a question here that is a data question for you,
Ooh.
Helen. What does NASA do once it's determined from data that there is a region that has a mosquito population carrying a disease? And I can answer that right away, that almost every region has mosquito populations that carry some kind of disease. Some of them are endemic, that you find them all the time every year. Other areas, like for instance, the outbreak we have on the East Coast with equine, Eastern equine encephalitis, it's episodic. So it depends from place to place. But would you like to talk, Helen, about how that database can be used by scientists?
Sure. So Rusty and I are actually working with a collaborator in Oklahoma who's really interested in the competition between different kinds of mosquitoes. So what's endemic, right? The kind of mosquito is a Culex mosquito that's endemic right now in Oklahoma, and it has the ability to transmit West Nile virus. And Oklahoma has had multiple outbreaks of West Nile virus since it was introduced in 2002. So now, Rusty, correct me if I'm wrong, but it's Aedes aegypti is now pushing up from Texas. And so they're really interested in monitoring for this arrival of a different kind of mosquito coming up from Texas. And so that's how they're using the information. And they are, so the principal investigator there is in close contact with the Oklahoma State Health Department. And so they're getting their eyes on it, and the mosquito districts would hopefully alert the right officials to respond earlier than they might have been able to otherwise. So we know that citizen scientists can and have made important discoveries like this, like a new kind of mosquito able to translate new and different kinds of diseases in that state. Citizen scientists can make those discoveries earlier than sort of the official networks, and that's work that was published by John Palmer in the journal Nature, and that work was done in Spain. And so that's sort of really inspirational work for the collaboration that we have going on in Oklahoma.
Right, and that's a really good point. I'm glad you brought that up too, Helen, because one of the things that we have in the U.S., as she said, there are these mosquitoes which are invasive mosquitoes, and these mosquitoes, they used both of them. The one which is called the Asian tiger mosquito came over in the 1970s in tires because they love those stagnant water that's found in the water that pools in tires. So when tires began to be moved from Asia, it was the sort of the used tire market. That's how they actually hitchhiked their way to the U.S. And now that particular mosquito is found all over the East Coast, and it's moving up to the middle part of the U.S. The Aedes aegypti mosquito actually was around a couple hundred years ago, and then it was eradicated in the 1950s. And it's now just beginning to come back again, and that's the Aedes aegypti mosquito, which is also known as the yellow fever mosquito. And that's the one that we're very, very concerned about, because that mosquito is a mosquito that is a really faithful vector for disease. And what that means is that because they tend to preferentially bite people, it means that the transmission is much more effective than some of the other mosquitoes. And so the fact that we have had one sighting of an Aedes aegypti mosquito in Oklahoma, and there are some in Texas, but only one in Oklahoma. That's why they launched this project, because they don't want to see any more. And if they find any, they want to eradicate them right away. So we want to get rid of those habitats. We want to let the public health know. So this is a way that citizen scientists can play a huge role in protecting their communities from disease. So that was a great example, Helen, that you brought up.
And thank you for the person who asked it. Maria, I see one about aerosol optical thickness. I'm going to give you my email, Maria, and you and I can talk aerosol optical thickness offline. I could geek out with you all day about dust and aerosol optical thickness. So Maria, look for my email in the chat.
Great. Okay. And it says here, please remind us of a few NASA links to classroom and outreach materials. Cassie, do you want to share your screen and pull those up, or Helen, would that be easy for you, or would you like us to do that?
If you guys can do it, that would be great.
Okay. Cassie, can you do that, or would you like me to do it?
Would you do it, Rusty? I'm on a lower bandwidth than you.
Okay, great. Okay, I'm going to share my screen now. And I wasn't prepared for this. You're going to see a really messy screen, and I'm really sorry about that. But going here to Mission Mosquito, do you see my screen right now?
Yes.
Great.
Yes.
Okay. So what you'll see here up above, and this is a question that Larissa had, you'll see that you go to globe.gov/web/mission-mosquito/overview, and there you'll see on the left-hand side we have a lot of different resources. Helen talked about the blog that we have, where we have a lot of student blogs over the summer that are very, very interesting to read, including the ones from the students that she just presented. And you'll see here also a place called resources. And if you click on the resource link, Cassie's done a great job of making these really easy to find. So you'll see that there are educator resources, there are resources for citizen scientists, and also some specific ones from museum and library. So you can identify which one of those you are, and you can go take a look at them. But here's just a quick overview. We've got a fun Zika Zap bingo game, which allows people to think about some of the not quite really, you wouldn't necessarily think these would be mosquito habitats like barbecue grills or old abandoned cars. They actually are tremendous mosquito habitats. We actually have some really fun fortune teller type things. You know what those are called? They used to call them cootie catchers, but we have 5 of those, and each one of them is set up so that you can play the game in pairs, And then after you go through the sequence of questions, you end up with a true false question that you can test each other, and there's points. And there's one for teaching about protection and prevention of disease. There's one for West Nile. We have one for malaria. We have one for Zika and dengue, and we have one that just talks about basic mosquito biology. We also have another one, which is grayscale, that kids can actually design and make their own cootie catcher mosquito tellers and test each other about what they've learned in the classroom. So that's really cool. Then there's a couple other things here, just rolling down here. We've got a couple, how to build a mosquito trap. We have a couple lessons. We have a disease guide that is now being formatted. It's right now in draft phase. And this is the most fun thing. We came up with something called the Zika Zine, and it is it's a zine about mosquitoes, and it basically in a very fun way, it sort of shows how citizen scientists can interact with mosquitoes. They can document the sites, they can take the pictures, and why it's important from a disease point of view. And this is available in 8 languages, including English and Spanish. So this is a great resource for classes. So anyway, you can go to this particular site, Mission Mosquito Resources, and find everything that you need. Okay? And this is the official site for Globe Observer. This will take you to all the resources that you need, whether you want to look at clouds or land cover or trees or mosquitoes. And there is a place here, up here, besides one person today asked about how to get the app. This will tell them how to do it. These are all the different tools we have on the app. And then here, Lead a Program is where you can go to find materials. So if you go to Mosquito Habitat Mapper, you can see that there are activities, books, videos, and presentations, and printables. And if you go there, you'll see that we have a whole bunch of different resources that can be used. There's a video right here that we did with students from Peru and Brazil. And overview is where, I think this is where we have the presentations right here. So yeah, here they are. So we have a whole bunch of little presentations. They're each about 20, 25 slides long that you could use in a classroom, for instance, or in a library setting where you can show people how to use the app, why it's important with respect to vector-borne disease, how NASA satellite data can be incorporated with mosquito data to come up with models. We have a fun quiz, which is you can use as a way to build interest, how to use the app the first time. There's a tutorial. There's one on how to use macro lens, and there's a whole presentation on how to identify specimens. So you'll see we have a lot of materials there available for you. So if there's something we don't have and you'd like to see, we're looking for new ideas. One of the things that Cassie and I and Helen have been talking about is maybe doing some very short 3-minute videos, show people things that we could then incorporate, that could be incorporated into a classroom very easily. Okay, so that is, okay, I'm gonna stop my share now.
All right. Thank you, everyone. Enjoy the rest of your day.
And thank you, Helen, for such a great presentation. We really enjoyed it.
Bye, guys. Signing off from NASA.